difference of squares. Now, I'll be honest, this is the big one. You go into classes that don't have a heavy math emphasis, but still have math involved. Biology, definitely some maybe some undergraduate, lower level finance classes, maybe some lower level economics classes. The very first Economics 101 or Finance 101. I've noticed, not a rule, but I've noticed that when they give you expressions to model certain things, those teachers often, and I'm generalizing, right? I'm generalizing. They don't want to spend entire class periods teaching students how to factor. They want to spend time teaching them about the implications of the results of the factoring. And so I've noticed that many times they come out with models that end up being differences of squares, because those are relatively easy to factor. Okay? And so here is our model. And we saw this in the earlier lesson when we were given a plus b times a minus b. It was just a consequence. When we multiplied that out, that middle term canceled out, and we were left with a squared minus b squared. And back then I had said, you don't really have to know that. It's a consequence. But now we have to know it. Okay, now we have to know it. A squared minus b squared is just a plus b, a minus b. So let's look at this one here. And again, this has to be a minus. So x squared minus 16 is going to be x minus 4 times x plus 4. And the one thing you got to be able to do is take the square root of this number. Now, that doesn't have to be a perfect square. It's nice when they are, and they usually are, to be honest, in here, but they won't always be. So square root of 16 is 4. So we get x minus 4, x plus 4. And that's it. Okay. Let me slide in another one here. You get a free example here. Just to make sure we got that. How about x squared minus 25? What's that one going to be? Oh, yeah, we have perfect squares here. So we're going to have x minus 5, x plus 5. You can see why folks, faculty that don't want to spend a whole lot of time teaching students how to factor, this is the ones they go to. They come out fairly nice. Not a whole lot of explanation, like in the last lesson we did where we had a not equal to 1 on trinomials. That's kind of a pain, right? If you're not used to factoring, you get better at it the more you do, but they're more than one-step problems. Okay, factoring 9a squared minus 25b squared. We should recognize these are perfect squares. 9 and 25, we have a squared and b squared. So we're going to have 3a minus 5b, 3a plus 5b. You have a multivariable perfect square. Okay, how about this one? Now again, one thing I always forget to show when I'm doing this until it actually comes up, look for a GCF, our number one rule of factoring. Look for a greatest common factor. Do I have a greatest common factor here? I sure do. 2 definitely goes into both of those. I'll have 2, and then I'll have 4x squared minus 25. And now, can I factor this? Yes, I've got 2 perfect squares, and I've got a subtraction symbol there. So that's going to be 2. Don't forget you bring down your factor. I'm going to be able to factor this into 2x minus 5 and 2x plus 5. Now, let me give you one for free. What if I had x squared minus 7? Factor that. Well, that's not a perfect square, but what is the square root of 7? We can just leave it as a square root of 7. Now, I'll be honest, in this class, we won't do many or any of these at all, but just sort of keep this on your radar. So just be x minus root 7, x plus root 7. And that would be it. Because what is root 7 times root 7? Well, it's just 7. Again, this is we will not have this in this class, but just sort of know that going forward, when you go into college algebra and other classes, you may encounter problems like that. How about this one here? This is a wolf in sheep's clothing. It looks super easy, yet I'll have over half my students miss this one problem alone. Is this a difference of 2 squares? No. It's a plus symbol. So this is prime.